Hello, uh, good morning. Uh, this is the last session of the electromagnetic theory. In this particular sessions, we are focusing only the numerical problems that comes under the electromagnetic theory, especially in the first part, divergence, curl. So we are focusing much about the physical idea behind these numerical problems. Okay, that means I'm much interested what happens to gradient of divergence of a vector, or what happens to divergence of a vector. The divergence of vector, positive means what, zero means what, negative means what. So when the field is going, the curl of a vector becomes positive means what categories of the field it is. The curl of a vector positive means what category. So this idea, so we are giving much importance. And before that, first we'll get the rhythm of simplifying some of the problem, and then we are going to discuss the concept based problem. Okay. This is the first questions, the first problems. Uh, Here it is. If phi is 4x square y cube z square, find the divergence of gradient of phi at these points. Okay. You may expect just the gradient of phi. You may expect the problem gradient of phi at 1, 2, minus 1, or the divergence of gradient of it 1, 2, minus 1. These. So all options are there. Uh, Here we are considering first the gradient of the scalar function. It's an equation for the gradient of scalar function I dou phi by dou x plus j dou phi by dou y with k dou phi by dou z. So this is an equation for the gradient of phi. Here dou phi by dou x means this function phi you differentiate with respect to x. Okay, 4x square y cube z to the power 4. So when you are differentiating, this becomes 4 into 2, 8x y cube z to the power 4. So that is going to be dou phi by dou x. Similarly, dou phi by dou y, differentiate with respect to y. That means 4 into 3, 12 x square y square z to the power 4. And then the last dou phi by dou z, here it is z to the power 4, 4 4s are 16, x square y cube z cube. So these are going to be the dou phi by dou x, dou phi by dou y, dou phi by dou z. So in this particular place, gradient of scalar function, you write these component values, 8x y cube z 4 and 12x square y square z to the power 4 and 16x square y cube z cube. Suppose the question this much, at 1 2 3 means you substitute the values here 1, and for this 2, and this is minus 1. So like that you substitute, you are getting the answer in terms of the number. If you want the magnitude, just go through the vector method, x square plus y square, square root of x square plus y square plus z square. So that way you can find out the answer. So here first we found out the gradient of phi. So this is the gradient of phi. Now I want the divergence of gradient of phi. So for that purpose, this del phi, I'll call it by the name f. Okay. So del phi f, divergence of gradient of phi. My gradient of phi becomes f. So what we actually find, we have to find out divergence of f. So this is a equation for the divergence of vector quantity. So dou f of x by dou x plus dou f of y by dou y plus dou f of z by dou z. So here you have to take the x component of the f vector function, y component, and here it is the z component. What is the x component? In the first case, this is f of x, 8x y cube z 4, and 12x square y square z4 is the f of y, and 16x square y cube z is going to be the f of z. So now you take dou f of by x by dou x. So differentiate this with respect to s. This is the answer. And differentiate this with respect to y. X square, this 2 comes here, 24x square y to the power 1 z to the power 4. Similarly, dou f of z by dou z differentiate it with respect to 16 3s are 48 x square y cube z square. So this is going to be the divergence of f. What is f? The gradient of phi. So divergence of gradient of phi is going to be this much. 8y cube z4, 24x square y z to the power 4, 48x square y cube z square 4. Now you substitute x equal to 1, y equal to 2 and z equal to minus 4, and this is going to be the final answer. You are going to get it. So this is just the method, the divergence of gradient of. So by looking into the final answer, you can conclude what is the value of gradient, divergence of gradient of phi. Now, this is another question. This is a concept based. Prove that this vector f 3y square zi plus 4x cube z square j 3xyk is a solenoidal. So this is the conceptual basis. If you are going to get divergence of the vector field value 0, then it becomes a solenoidal field. That means the condition for the solenoidal field is divergence of f equal to 0. The meaning, the flux entering equal to the flux leaving. Okay, there is no source or no sink. So that idea. So first, to prove this is going to be the solenoidal, you have to find divergence of f, and if that divergence of f value becomes 0, then you can confirm it is a solenoidal field. If it is not 0, then it is going to be the non-solenoidal, or in that case, if you are getting the positive answer, then it becomes the source of the vector field, and if it is a negative, the sink of the vector field. So this is the formula. Divergence of f, dou f of x by dou x, dou f of y by dou z, and similarly dou f of z by dou z. Now first differentiate it, 3y square z with respect to x. There is no x component, so 0. Similarly, y component is 4x cube z square. Okay, there is no y component, differentiated 0 with respect to y, and here there is a z component, differentiate with respect to z. There is no z component in this, 0. That means first, second, third term 0, or in general del f equal to 0. So what is f? This is the vector field. If del f equal to 0, this is a proof that that particular field is going to be solenoidal in nature. That means the flux entering equal to the flux leaving. Okay, so this is what the one. They may ask this question, and they will ask you to find out whether the field is source category or a sink category, or it's a solenoid, non-solenoidal or solenoidal, like that. Okay, so this is second category. Now this was the third type of questions. Okay, here after finding the value of divergence, we are going to confirm whether it is a divergence or a convergence, or it's a source or a sink. Okay, this is a vector field given, f equal to 2x square zi y square z4j minus xy square zk. They are asking calculate divergence of vector field at 1 to minus 1. So as usual, this is a formula, and this is f of x component, y square z4 is the f of y component, minus xy square z is the z component. Okay. Now first differentiation, dou f of x by dou x, that become 4 x z. Okay, here x square is there, so differentiation 2x, 2 to 4, 4x, and here it is y square is there, so differentiation 2y z to the power 4, and here it is minus x y square z to the power 1, differentiation 1 minus x y square. So this is going to be the divergence of F, divergence of this vector field, 4xz plus 2yz to the power 4 minus xy square. Now you substitute it. The so-called x value 1, and here it is going to be minus 1. So this 4 term becomes the minus 4, and in the second case it is 2 and 2, that becomes 4, and minus 1 to the power 4 is 1. This is going to be the 4. So first is minus 4, second is 4, that 4 cancels, and the third term x value equal to 1 and y value equal to 2, square it. So that is going to be 4, but minus is already there, therefore the del f is going to be minus 4. So this particular field is acting like a sink, or it is the convergence. Del f value we are getting it as a minus, therefore the idea is that field is acting like a, the flux is entering there, okay, so not leaving it, so flux is entering, so this is the convergence electric field or the convergence field. We should not use the word electric because we don't know whether it is electric field or magnetic, it is just a field. So convergent field, from the value of divergence of f you have to make conclude in the conclusion. In the previous problem we took the case divergence f equal to 0 solenoidal. Here it is not 0, that means it is a non-solenoidal field. So in this comes under the convergence category. Now this is the next. See, when you are speaking of del cross f, you should be very clear whether it is a rotational field or an irrotational field. If del f value you are going to get 0, then it becomes an irrotational field. If del s value is going to be not non-zero, then it is a rotational. If it is a positive, anti-clockwise direction, and negative, the clockwise direction. Okay. So here the vector field is given 2xzi minus yzj plus 3xzk. Find del cross f. So this is an equation for the del cross f. I, j, k, dou by dou x, dou by dou y, dou by z, and f of x, f of y, f of z. This is f of x, minus yz is the f of y, 3xz is the f of z. Okay. So this del cross f, general equation, I dou f of z by dou y minus dou f of y by dou z. See, usually in these matrices you are taking plus, minus, plus, but I have taken here the plus. So the reason is I just changed the terms here. If it is minus, it should come like this: dou f of z by dou x minus dou f of x by dou z. But I have taken plus here, therefore inside I reversed it. So dou f of x by dou z minus dou f of z by dou z, dou x. So this part you will be very careful. Usual matrix analysis plus, minus, plus. So but here I have taken plus only, means inside the components are interchanged, this side and this side. And then k, look at this, k dou f of sz by dou x, f of y by dou x, and dou f of x by dou y. So this is the term. Now take one by one. First term, dou f of z, x z is there here, but differentiate with respect to y. Okay, differentiate with respect to y. And then you're getting this term. Next, this particular term 3xz, differentiate with respect to y, but there is no y component, 0. You go to the next term, f of y minus yz. Okay, minus yz. You differentiate with respect to z. So then what you are getting? Y. So that is the first. In this, the y component is left. And next you go through this, f of x, this differentiation with respect to z, 2xz, z is there, so remaining term is 2x. Similarly, next term dou f of z, 3xz is there, differentiation with respect to x, so that means it becomes the differentiation with respect to, differentiation with respect to x, so therefore it is the 3z. Okay. Then the next term, f of y, differentiation with respect to x, there is no x component, 0. Then f of x, differentiation with respect to y, there is no y component, 0. Okay, so now this equation reduces like this. Okay, so this part, the minus is there and this minus, so that become the plus here, yi. Then here 2x minus 3z, 2x minus 3z, careful, 2x minus 3z, 0, and this is going to be the final term, x, y, z. So here the z component is not there, therefore 2x minus 3zj, that much only. So this is the one value. Now if you are going to substitute the value to the x and y, you are getting del cross f. If del cross f is going to be 0, then it becomes the irrotational. If del cross f value is non-zero, then it is a rotational field. So by substituting some value, you can identify that. Okay. Now this is another slightly different. We have discussed this type of question, but a slightly different one. So what is this is, there is a vector A 3xyzi plus 2xy square j minus x square yzk, and this is the vector, and a scalar function is given, phi is equal to 3x cube plus yz. So we have to find out divergence of phi a at this point 1 minus 1 1. Okay, so divergence of this phi a, it is not the gradient. In the first question we have taken divergence of gradient. It is not gradient, it is a multiplication of the scalar function to vector. So first we will do that one, the phi a. So phi a, what is phi? 3x cube plus yz. A is this. So individually one by one term you multiply 3x cube to this. Okay, so 339 x cube and x here, so 9 x to the power 4 yz. That is the first term. Okay, and then second term yz to this one, 3x y multiply this side y square, z multiply this z square. So the second term here is 3x z square y square. Similarly to this second part, 2x y square, first part 3x cube, 3 into 2 to 6, and x cube and x, so that becomes x to the power 4. So 6x to the power 4 y square. And the next part is yz, 2x y square is there and is y cube, and z, 2x y cube z j component, and then minus first 3x cube and here x square, x to the power 5 y z, and then second component y and z multiplied by y and z become y square z square, or it is in general x square y square z square term. I took the minus outside, so this is the k. The first term is going to be my f of x, second is f of y, third is f of z. So now divergence of f, dou f of x by dou x plus dou f of y by dou y, dou f of z by dou z. Okay, so because of this f of x term, if you differentiate with respect to s, 9 4s are 36 x cube y, and then here it is just x to the power 1 differentiation, we are getting 3z square y square. Similarly here differentiation with respect to y, therefore 6 into 2 12 x cube y, and here it is 3 into 2 x, 6x y square z, and here it is differentiation with respect to z, z to the power 1, so therefore 3x to the power 5 y only, and in the second z square is there, 2x square y square z. Now you substitute the values 1 1 1 minus 1 and 1, so in these you are going to get the minus 26. Okay, so this is simple. Divergence of something we got negative, that means it is going to be the non-solenoidal field and it is belongs to the convergence category. Okay, and this is another proving type, simple. Divergence of 1 by r. Oh, it is not divergence, it's the gradient of 1 by r, where r is the position vector xi y z. Okay, so we have to find out the gradient of 1 by r. So for that we'll treat like this. 1 by r equal to phi, say. So then what happens? Del phi, the gradient of the scalar function I dou phi by dou x, j dou phi by dou y, k dou phi by dou z. So this is going to be the gradient. So one by one term you differentiate dou phi by dou x. So what is phi? 1 by r. Okay, so 1 by r, 1 by r, r is here, x square, y square, z square to the power half. So 1 by r is this 1 by x square plus y square, z square to the power half. So this is taken to the denominator, x square, y square, z square to the power minus half. Differentiate with respect to f. So x to the power n category, n x to the power n minus 1. So here minus half, then x to the power n minus 1, minus half minus 1, minus 3 by 2, and thereafter differentiation of this x square 2x. Okay, so minus of 2x and then this to the power minus 3 by 2. X square plus y square to the power minus 3 by 2, you take it to the denominator, that becomes 3 by 2, minus kept as it is 2x, this is the first term. Now no need of doing the remaining term, just change x, y, z. Dou phi by dou y, the identical. In the place of x, you write y. And in here, in the place of y, you write z. The remaining terms are going to be same. Now you take, observe here, 2 here cancels. Here also cancels. Here also cancels. And in all cases, the minus is there. That you take it outside. First part it is xi plus second part it is yj, and in the third part it is zk. Okay, xi, yj, zk. That is nothing but our position vector r. And in the denominator, x square plus y square z square to the power 3 by 2. Look at x square plus y square z square to the power half is the magnitude of this. Okay, and to the power 3. So that is r to the power 3. Okay, so this is the unit vector r to the power 3. So the gradient of 1 by r is nothing but minus position vector r by r cube, or in terms of the unit vector, vector r is magnitude of r and the unit vector. Magnitude of r and the unit vector. So magnitude of r and 1r cancels here. So this is the unit vector r cap by r square. So this is going to be the final answer for del. So here you can expect del of 1 by r equal to n. They may ask you to prove in the same manner. You have to go through this. And these some of the question I will consider you to do homework. And the first, show that this vector is irrotational. That means this value, if it is going to be 0, del cross r value 0, then it becomes irrotational. And similarly find the del to the gradient of r to the power n, just what I did it, and gradient of log r, this is a proof. And then this is another question we have to, is the field is solenoidal. By assuming del of f equal to 0, we have to find out the values of p, and then divergence of r is 2 by r. So these I am giving it as a assignment questions. Okay, thank you.